Let's continue our discussion of delta H. Remember, delta H is the enthalpy or the heat of a reaction. And we said in the previous video that there are several different ways that you can determine what the heat of a reaction is. One way is to measure it in the lab, and this is through a process called calorimetry. The second is to calculate based on the reaction steps using something called Hess's law. The third is to calculate the enthalpy from the heat of formation. And the fourth is to calculate from bond dissociation energy. As you go down this list, these become approximations, and so the best way to always determine the enthalpy is to measure it in the lab. And so if you can't measure it in the lab using calorimetry, then you can calculate using Hess's law. If that won't work, then you can calculate from heats of formation, and if that doesn't work, then you can use bond dissociation energy. The two that we're going to talk about in this video are 1 and 2. So we're going to measure it in the lab using calorimetry and calculate using Hess's law. Okay, so let's talk about calorimetry first. So calorimetry is used to measure the heat of a reaction. Here's the experimental setup that you use for calorimetry. So the idea with calorimetry is you have some sort of insulated vessel. That's why this is airspace, because you're not going to lose any heat through air. So you have an insulated container with an insulated lid, and then you have a reaction vessel that's in the inside of that. And the reaction vessel is where your reaction is going to take place. So you combine the 2 or 3 or however many reactants you have into that vessel, and then as the reaction goes on, you measure the temperature. Okay? And often these include a stirring stick so that the reaction is being continuously agitated. So again, the idea with calorimetry is you just combine your reactants and then you monitor what happens with the temperature, and you're measuring the heat of reaction. The way that you calculate the heat that's given off or could be absorbed through calorimetry is using this equation. So Q is the heat. Q is equal to the specific heat, which this is a constant. Okay, so you just look up the specific heat for whatever sort of solvent you're doing the reaction in. The mass is the mass of everything that's in the beaker. Okay, so you take the mass of what's inside that reaction vessel, and then the change in temperature is what you're measuring from the thermometer. Okay, so again, the heat is equal to the specific heat, which is a constant that you look up in a table, the mass of everything that's in the beaker times the change in temperature. The relationship between the heat and the enthalpy is that enthalpy is equal to the heat, so this is what you're calculating here, divided by the number of moles. So enthalpy is always given as the heat per mole. Okay, if you can't, for some reason, do calorimetry in the lab, you can use Hess's law to also approximate what the enthalpy change for a reaction is going to be. And Hess's law says that the overall enthalpy change for a reaction is equal to the sum of enthalpy changes for individual steps in a reaction. Okay, so the idea with Hess's law is that when we go from reactants to products, that's not just one step. There are individual steps that you go through to reach the product. Okay, let's look at an example. So here is, in this reaction, we're making ammonia. So we're combining hydrogen gas plus nitrogen gas to make ammonia. And there's the delta H for that reaction. So when you combine hydrogen and nitrogen, it doesn't in one step go to ammonia. It goes through what are called intermediates, and those are shown by that top line. So as we go from reactants to products, first we have to go to the intermediate, and then we go from the intermediate down to the product. So if we can measure the enthalpy change for those individual steps, so in other words, step 1 is going from the reactant to the intermediate, we have a delta H for that value. Then if we have a delta H for the second step, which is going from the intermediate to the product, the overall enthalpy change is just going to be the sum of those two. Okay. Let's put some numbers with this. Okay. So here is our step 1. Shown in A. Here is step 2. So step 1, we're combining hydrogen and nitrogen and we're forming an intermediate. Step 2, the intermediate is combining with hydrogen to make ammonia, our final product. We have a delta H for both of those steps, this is the overall reaction that we want to find the delta H for. So if we just take the sum of delta H from step 1 and delta H from step 2, that will give us the overall enthalpy change. So really what we're doing is we're just adding those two together. So if you add those two together, you'll see that the intermediate N2H4 cancels out. We have 3H2 plus N2 gives 2 ammonia. Okay. So really all we're doing is adding those two delta H's together. So this is a pretty easy use of or example of Hess's law because we're just adding those two reactions together. But when you do problems involving Hess's law, it might be a little more complicated. So for instance, you might have to reverse a reaction in order to get your overall reaction. Remember, if you reverse a reaction, you change the sign of delta H. So if delta H is a positive value and you reverse it, then delta H is going to have a negative value. You also might need to multiply a reaction by a certain coefficient. So remember, if you multiply it by a certain factor, you also multiply delta H by that same factor. Oh, and I should write the answer up here. So this is negative 92.2 kilojoules. Okay. When would Hess's law be used? So remember I said that calorimetry is the best way to measure the heat of a reaction. So why would you not just do that in the lab? When would you use Hess's law? And in some instances, there are heats of reaction that are very difficult to measure. For instance, if you have a measurement of combustion where you're adding oxygen to something, that requires some pretty sophisticated experimental setup, because you have to monitor the pressure of oxygen, and so that can be difficult to do. Or there might be some instances where measuring the heat of reaction is unsafe. So if you have something that gives off a lot of heat or gives off a vapor or a lot of light, that might be something that is unsafe to do in the lab. So if you can't measure heat of reaction directly using calorimetry, you can use Hess's law to approximate what that enthalpy should be.